All right, hello everyone. It is 3 o'clock. We will be beginning our talk on the computer and embedded systems concentration. We have Dr.Yuhua Chen here with us, the advisor for this concentration. So let's get it started. Okay, here we go. Okay.
Sure. I think it's really too high.
We have Dr. Bronco.
Okay, yeah, sure. Can't compete with him. Okay, yeah. Welcome for your attendance, and either you're actually watching this live or just watching the recording of it. I think if you're in this session, you're in the right place. Okay, I'm the coordinator for our computer embedded systems track, and also I'm the advisor for the CP track. And there are lots of commonalities among them, and if you are kind of hard to decide, you can email me and I can send you the video, or I can actually meet you to discuss which one's better for you. Okay, and my name is Yuhua Chen, and I'm the only white Chen in the department. And my email is my full name at uh.edu, and you can reach out to me anytime. And then just kind of a tradition, I reply to every single student's email. I may not reply to some faculty members, but I never fail to reply to a student. So in case you didn't get my reply in reasonable time, usually 24 hours, but after 3 days, if I don't reply, that means I didn't see it. Okay, I don't have a working queue that actually, because some staff had a kind of backlog queue. I try to do everything the day or the day after. So I will not be offended if you email me again, just reply to your first email. And I would like to say, once we start a communication, you always reply to the previous email. Don't start a new thread, because I want to see all the conversation we had before, even say for a year ago. So suppose now you contact me for something, right? The next time you want to approach me, just reply to that email so I can see instantly the things we talked about before. All right, and I always reply to students' email. So if I don't reply, I didn't see it. All right, so you're in the right place, because when we say embedded systems, nowadays, it's everything but the laptop computers, the desktop computers. I don't even know if you still have one, or the servers at Google's data centers. Everything else is considered embedded system. Even your oven, maybe the oven could be internet connected. Even if it's not connected, it's a perfect example of old traditional embedded systems, because it has all the controls for the oven kind of valves and also the timer and so on. And now the newer refrigerators are even more smarter, and then it actually have maybe the volume controls, the item controls. It will send an app notification saying, oh, you're low on eggs, please put on your shopping list. So it's fantastic. And all the cars are really a huge use of embedded systems. The modern cars are over 1,000 processors. With the electronic cars, it's even more. So you can find jobs anywhere, from the car industries and computer industries and oil and gas industries. And as you can see the picture here, it's an illustration of a well logging tool, because the human cannot going down and peek, right? The only way is to send embedded systems. It has embedded sensors, it has data acquisition systems, and even have decision-making systems. Just while they're drilling, they're making decisions constantly in real time. And these all only be achieved by the embedded systems. Again, NASA has tons of jobs over there, and they have hired many of our students, and they are asking for more, just as of last week. All right, so this is kind of all the opportunities I just mentioned. And locally, in case you want to stay in Houston area, there are plenty of opportunities. HPE and HP now, unfortunately, they are actually, I have to say, very politically correct. So we'll have HPE, which is the HP Enterprise, and HP referring to HP Inc. Okay, and NASA and many NASA contractors are there. And the reason I learned that actually IBM has a branch here, and they're looking for my students. So tons of opportunities here if you want to stay here. And again, in case I assume most of you are maybe coming from the Houston area, you want to be a little bit away from home, right? But still coming back when your parents are in need. Then there are tons of opportunities in Austin and Dallas, right? They're just a couple of hours drive away, and you're still in Texas, and tons of companies moving to Austin. Even if those are without the headquarters, they are having a huge branch in Austin. So tons of opportunity there. And of course, if you fly to California and other places in Oregon, there are tons of opportunities looking for embedded engineers. Okay, and before I finish this slide, there's one at the bottom. It may not show on the real degree plan that obviously is that it's hard to actually learn control theorems after you graduate because there are lots of math and principle and theory behind it. So if possible, schedule one control course in your degree plan. But if not, I'll talk about the master's program. You can actually take a master's control course once you're in those programs. But all the robotics need embedded system designers, right? And driving a robot arm or everything is all about control. So if you know control and embedded, that will be a best. Otherwise, you can write C code or embedded C code, but don't know how to control the robot arm. You will say, suppose I don't know if the video I can. So basically, if you want to move the robotic arm, you want them to move faster, right, in the middle part, but stop at the right place. But the speed is controlled by the control principles. What you want is to start to accelerate a little bit more, maybe not visible with this short distance, but you don't want to have a full speed and suddenly stop, right, at the destination. So the control theorem allows you to design your system to slowly accelerate and slowly deaccelerate, and it will stop at speed 0 at destination place. So those things are very hard to understand and learn after you get out of school. So please take a control course if you could. And today we're going to have lots of information for you. And this time is actually more than what I gave last year because there are new opportunities that will give out to this year's student. Okay, so first principle first. And we assume that you will actually sign up for the electives after you take electronics and micro P and digital logic design. Okay, and you see the dotted lines right here for micro P. I will say these are for historical reasons because older days, those were called 4436. So people may not be through the program before they hit a high level course like the course of, that's mine, Advanced Digital Design. But right now I'm kind of accept a case by case basis. So there are a few people who really want to advance to the next level while taking the micro P. I'll maybe get an interview with the student, see if he or she is ready and let you in. But otherwise, try to squeeze in all the 3 main courses before you hit my advanced digital design as well as the other one. I think the other ones are hard prerequisites, but for my course, I will give exemptions to a few students, but otherwise they will hit my course after they take micro P. That will be a great help. Okay, so once you finish the first layer, and those are the things I really want all the embedded systems to consider at least 2 out of 3. Because on the degree plan, it's not like that. It will say either 4437 or my course 5040 will fulfill your mandatory requirement for this degree plan. But I always say that you have to take embedded systems because embedded system course teach you how to program those embedded processors. That's the notion of embedded system to 95% of the world, okay? In some extreme definition, what I teach is also considered embedded systems, but I teach FPGA and ASIC design methodologies. Those are not really considered embedded to many people's eye. And if you just look at the degree plan, which I'll show later, and just bypass the 4437 and only take my class alone, even drop this advanced micro because I was in the pure electives, then you end up stuck with my course. And when you actually look for jobs and they say, oh, you are graduating from embedded concentration, I expected to do certain things. They said, no, it didn't really hit my curriculum at all. And so that's a bad thing. So for me, before I sign the degree plan, I need to make sure that you hit at least one of these embedded system classes. Because it's ranged, say fall, we have a single one, 4437. And in the spring semester, we'll have two courses, my course and advanced micro P. But it will be really hard for anyone to take these two at the same semester unless they actually schedule 1 year apart. Otherwise, it will be really bad idea because I'll talk about later, there's extremely high load my ADD class. So most of the people that in this cloud will be seeing the embedded system as well as either my advanced digital design or the advanced micro P. Okay, so that's a general idea. I guess you'll see that you're going to make lots of decisions, and the degree plan form doesn't reinforce you to take, say, for example, this one and maybe one of these other ones. So I want to make sure that whoever listens to my talk, putting this one on your degree plan and then select these two and to put onto my degree plan. And you have to pass my interviews for ADD. The interview could be by email, by Zoom, or in any suitable forms. Okay, so I basically already talked about these three, and then I'll talk a little bit about what is covered in each class. And the first class is what I recommend for everyone in this track would take is the embedded systems. It talks about the embedded processor, which you can buy off the shelf. And the most popular one is ARM processor. We are teaching that for the top two classes. And we're using industry standard. We'll talk about how you actually utilize those and to make a project that maybe most likely will be a robotic car that will traverse some maze or actually detect obstacles. Okay, so that will give you a general idea about real-time systems, but not in the depth in terms of the OS and the internet part of it. And most embedded systems are connected to internet, as you know now. So the next class actually is split into two kind of funny names. And the name that stuck with undergraduate degree is still called Advanced Micro P. And the graduate level has a modern, actually looking title, which is called Intro to RTOS and IoT. For those who don't know what RTOS is, it's called real-time operating system. That's the most needed thing for industry because the regular OS is not reacting to any of the sensor data in real time. So they may be busy doing some file management while you have a critical sensor signal coming in. If it's get missed, then it will be a disaster. So all the critical industry are using RTOS, which is real time. That will actually cause an interrupt and priorities of different inputs and take care of those in order. They can actually stop what they're doing at low priority and attend some high priority things. So that's elaborated in this class. And then IoT is a standard for Internet of Things. That's the buzzword right now. Everything is connected. So basically it's Internet of Things, the little things, embedded systems. And those are the modern concepts of embedded system, literally. So a couple of years ago, we filed the title change to both our undergraduate session and the graduate session to change the name to Intro to RTOS and IoT, because once you hit micro P, and people may or may not have bad experience with micro P, that's why we want to not only get rid of that barrier, but also really update to reflect what's in the class. But funny thing is that our application to the graduate level session got accepted, which actually now carries a new name, but our application to the undergraduate session got denied. So now we're not going to find any updated title request soon, so it's stuck with two titles. But it's if you look at the content, it's really RTOS and IoT, what is most likely needed by the industry. Okay, so those the top two are working with processors. Okay, the last one is concerning how to design processors and any customized logic. It's called advanced digital design. We use a type of software called Verilog HDL. HDL stands for hardware description language. And for people who don't know FPGA, it's called field programmable gate array, which probably still doesn't make sense by the name, but it's actually a chip that's pre-made. Inside the chip, there are actually different types of SRAMs and logics to remember what you want the circuit to do. So basically, it's a circuit to be programmed on the go. And the benefit is that first, as a student, whenever you design a custom logic, older days, it went through the ASIC process. It's super expensive to spin off a chip. It probably costs $1 billion. So students didn't really get to practice for whatever they design because they cannot afford it. So now with APJ being affordable, and you can see instant results. So all my classes are lab-based. You design your circuits and you download to FPGA, you see the results and you debug. So it's really fun to finally take the FPGA kind of getting the signals alive and to the point where you want it to be. So it's really fun, but it's lots of work. And to compare this with other two courses, I would say it's at least doubling the load because we have very strict lab deadlines. For example, most of the labs are on the 2-week kind of time frame, but these are tremendous work on those labs. Okay, and then we take advantage of spring break. So one of the hardest lab is spanning 3 weeks time frame, and of course the middle week was the spring break. So I always encourage students to make commitment to spring break for my course, otherwise you're going behind. So there require dedications to it, and there are lots of things going to the design because there's no help of operating system at all. And whatever you do, if you don't connect even a single signal right, it doesn't work. Even this morning, I actually got an email from a student who actually wanted me to help with debugging process last night. And eventually she found a bug because she misassigned one of these pins to the right number. So of course, when you push the button, if the pins is messed up, it doesn't take the signal. But even the signal gets successfully into the chip, and it has to traverse all the logics. And who's touching those logics? Only you. So that's why FPGA is hard, but it's really fun. But it's only suitable for probably 1/3 of the population that will listen to my talk today.
Ms. Chavali has to leave at like 3:30. Do you think she could give her talk and then we can continue with yours?
Oh, I didn't know there's another speaker.
Yeah, we have two more.
Oh, yeah.
Sorry.
Okay, I didn't know about it. Let me see if I just the break. Yeah, it's perfect place. So you can cut this and we'll assemble the total video later. So okay, yeah, okay, yeah. I didn't know there's another speaker.
All right. Let's see. Let me spotlight.
Are you guys able to hear me?
We can. Your audio is a little bit muffled.
Is it better?
It's a little better.
Okay, I am using
AirPods.
AirPods.
Okay. I think it's good enough.
You can have the presentation that Dr. Chen had up because I think that would be a pretty good start. And since mine is, I'm only going to do it for a shorter time. I should use that. So are there like folks in the room as well, or are they just online?
They're all online today.
Oh, okay. Slide number 5 would be fine. Since you're right there.
I'm sorry?
Slide number 5.
Oh, slide number. Okay, understood.
Perfect, thank you. Hi everyone, Bala Chavali. I actually did one of these things for a shorter time the last time I was here, but maybe today is also another quick one. I went to University of Houston, graduated as an electrical engineer with computer option back in the day. For sure now more than a decade ago. Since I graduated from University of Houston with my engineering degree, I worked at Texas Instruments, I worked at Altera, I worked at Intel, and now I'm working for AMD. I worked on embedded devices that go into industrial, automotive, medical, I guess some type of power plants and aerospace, and also if you know the Ingenuity, the NASA one that went up into the space, One of the microcontrollers I worked with went up there. That's controlling the braking part of that Ingenuity back in the day. I mean, I guess it's still up there. So I worked on embedded that actually went across quite a few markets and quite a few different type of products as well. Are you still able to hear me?
Yes, it is a little bit muffled, but I think it's good. We can understand.
Okay. I can try my other headset if you give me a.
Sure.
How about now?
Yeah, I think it's good.
Okay. Yeah, so I did quite a few products. So one, I guess I kind of want to say three, things about embedded. Embedded, you are not like when I sort of started doing embedded way back when, I thought I probably will have to just do embedded as like board design. Embedded has so many options that you're able to readily jump from one area, uh, let's say one product line to another product line, such as going from aerospace and military into automotive, or from automotive into medical, or from medical into other things, right? So you're able to go across all those different products. That's one. The second part about embedded is that back when I started engineering, I thought embedded was all about just, putting together the board, putting together the parts and just doing the connections. Absolutely not, which is part of the reason why I had this slide. You can start where you're the architect who is defining what needs to go and what the function of that SoC would be, right? Which is a system on chip. Or somebody defines it and you probably are the RTL, person who is writing the Verilog and the VHDL and writing that code to make that happen. Okay, well, okay, I don't know if I want to do too much of the RTL piece, which is perfectly fine. Then you can become the verification engineer, which you're whoever actually went and designed it, whoever went and said, this is what I want the functionality to be, you're going to be doing the verification. And compared to before, now there's so many different tools and so many different ways to do simulations, for you to do mixed signal analysis, and for you to be able to do design checks. There's a whole lot of options as part of the verification, which is what happens after the design phase of it. Once you're done with the verification piece of it, in the background, they already started the PD, the synthesis, and the design layout, right? And for most of these SoCs, which are now, pretty big in terms of like the diarrhea, you have so many different places in terms of whether it's the analog part of it, the digital part of it, for layout and synthesis. Once that's done, okay, even that I think is too different. You're now able to do post-silicon, which is where you're now testing all these things that are already been hardened, that are now, that your silicon comes out, and you make sure that are they doing the functionality that it's intended to do. Now, if you say, I want to work a bit more higher up, you take your device, you connect it with, it could be motors on one side, it could be sensors on another side, it could be a keyboard on another side, it could be any type of input or any type of output, such as a display, an audio port, or on the other side, you're driving it to a PCIe that's driving data to another network. You're able to go across all of that. You build that system together and you actually make a component. So in embedded, you have the opportunity to actually be in any phase of it. Now, let's say you actually work on all these different phases and you have enough experience, you can now sort of consider yourself like a senior person or a director, where you're telling people how to execute to make this better. So I think over the course of my 20 years, I've done the verification. I've done the verification and the design piece for a good portion at TI. I've done a bit on the validation piece with emulation, FPGAs, SoCs. Then I started doing system, which is where I'm putting together a couple of my braking stuff. I've done a bit of sensors. I've done displays. So I built system solutions before. And later on, then I really just got into system architecture, and I've been an architect, where I overlook all the different pieces. And I'm also telling them what are the type of challenges that they can encounter and how to overcome those challenges throughout this entire phase. And this phase that I'm talking about, whether it is starting from architecture, product requirements, all the way to the end, could be anywhere from 2 years for a device that you're just spinning over and over again, or it could be about 4 to 5 years if you're doing everything from the scratch. Right? So, one of the, again, as I said, you have the ability to go across so many different products with embedded. You have the ability to work across so many different aspects, even within one silicon. And the third one is that, back in the day, and most of the people are like, oh, we love to travel, we love to do this. With embedded, you actually now get to do that anywhere in the world. I work with teams that are out in Asia, whether it is, Shanghai, Malaysia. I mean, there's so many different places within Asia I think I've traveled to and I worked with. And then you are able to work with Europe. Europe, I think it depended on the type of markets I was focusing. If I was doing automotive, if I was mostly concentrated, most of the automotive stuff and industrial, I mostly dealt with like Europe, like whether it's Germany or France and other places. When I was working with like industrial, I was working with a lot of like Canada and North America. And we used to do a couple of the actual design centers with Mexico, and there were two other places within, I believe one of them might have been Costa Rica, down in South America and Central America, right? Like you do get to, travel and you get to go work with so many different teams across the world.
That definitely sounds nice. I'd like to travel around someday.
Yes. So with Europe, I hated going during winter time, but I've been to Norway, in the middle of like February, which is the worst thing ever, right? I've been to Munich. I've been to so many places in Germany. I don't even want to count. But even within Italy, you think of Italy as just tourist place. There are actually quite a few of the EDA type of vendors and different type of tools that come out of Italy. So I was able to do a work trip for Pisa for like 10 days, right? Eating local food. And I mean, it was amazing. But you get to do that. And when you work out of Japan and Korea, there are a bunch of automotive vendors there, right? Like there are a bunch of car guys that like Nissan and Denso and stuff, right? So when you work with that and you get to see all of those beautiful places, including Malaysia. Believe me, that's one of, I think, at the top of my list up there. But yeah, so you get to travel too, and you get to learn all the different cultures, but you get to work on all the same type of embedded stuff.
Definitely.
Any questions?
Does anyone in the chat have anything they want to ask? Let's see. Well, while we wait on them, it seems like there's a wide array of fields you've been able to work on, and it seems like there's a wide array of fields open to our students who are interested in this concentration. Could you give us an example of a project that you enjoyed a lot and that you'd be willing to share with us?
Sure. I think the NASA Ingenuity is a pretty good project, right? That's the one that actually, the rover that went in, right? And that's the one that's actually jumping, hoping, and then taking the images of, the Mars right now, right? So for sure, when we started that project, that was not what that project was meant for. That project was meant for a braking system in quite a few of the German auto cars, okay? But, that was a pretty new technology, both from, technology, I'm talking about process technology, right? Like whether it is like a 65 nanometer or a 130 nanometer, process was completely new. The architecture, we knew that we had to do a lot of reliability and resiliency features into that device because it was going to be doing what we call fail-safe type of operation, meaning even if the device fails, you still be able to operate it. You still need to be able to get it. So essentially, whenever something is wrong in your car, as soon as you start the car, you get a light that says something is wrong. So just like that, you got to know if something is wrong in your car, something is wrong in your system, that you get some sort of warning. And so we built so many of those features into that SoC that we later on found out that all of those features to drive that system from one place to the other, they were able to do it. And any type of warning that gets sent from that system, it actually goes to, I think, a Qualcomm part, which is the one that's actually driving the information between that system to, essentially back to the rover and then, come back to Earth, right? So, I mean, I think it's a pretty cool project. We didn't envision that to be one of the, projects, but, they were also able to use it there.
Right. Yeah, sounds really cool.
Yes. I do have to drop off. I got a hard stop, so thank you so much. And maybe next time I get to spend more time. Thank you, Dr. Chen. Bye-bye.
Talking about all these things, and then those are actual components needed from the real system you just saw earlier. And the next thing, okay, and I'm going to talk is that you are the decision maker, and being embedded is a challenge because you have to make so many different selections, making so many your critical selections, not only for the degree plan, but I will say later for your life career. And again, I'll explain this to make the things easier. I tell you which one, the course, and make sure that you pick all the core courses we think important for embedded. Then the other things are the wish list, meaning that it will enrich you. But I think if you flip them back and forth, then you will not be able to land a job with the things you want. So I want to show you what the core courses to make that happen, then all the recommended courses to support those. Okay. And again, if it's too much for you, you can easily switch to CPE, which you only have to make 3 decisions. So there are 3 decisions, but you still get pretty much all the things that we will be covering today. So just this, that's for embedded concentration, and that is for CPE. Okay, but both actually share the same core courses and will get you to where you want to be. Okay, and this is excellent. The previous talk just show how important our curriculum is. And especially I'm going to talk about the 2 new addition to this mix, which are called short courses. And what I want to make sure is that you're not simply filing a degree plan. It's literally your career plan. Okay, so the next maybe a couple months when you actually fill in that form and hand to me to get signed off, that really dictates where your future will be. All right, so hopefully you can have an informed decision made, and this is why I'm here to help you. Okay, and our core curriculum are anything but blue. Okay, and those give you pretty good foundation on the, for example, if you see it on screen, it was the initial, the theory, and then the design. But then remember the next step is the prototyping. And in the middle, you saw in the earliest speaker's talk that it actually has real world IOs. That's when the theory or ideal world meeting the real world. And that's what we actually found missing in our curriculum until today. Okay, so you are the actual first audience to hear this, and you are the first batch to get this gap filled. So we just recently creating 2 short courses. Those are not full credits, but really help you to fulfill the entire chain for your very successful career. So the courses are called embedded system interfacing, and there's another course that actually verifies the FPGA designs. It's called UVM, which is Universal Verification Methodology. That's an industry standard for any verification of the chips. And the interfacing, as you can see, remember the flow that from the ideal design, theory, design, and then it meets the real world where you can see those ugly analog sensor signals, and you have to drive the actually non-ideal devices, and you have to deal with all the interfacing standards because all your chips are interfacing with CPUs, GPUs, FPGAs, and some customized devices. So that's where actually it was lacking. Just imagine if I deleted these 2 blue boxes, it would be actually 2 big holes there. And that's what actually learned sort of a hard way. And in the past 2 weeks, I recommended maybe over 10 students for job interviews because this year they had tremendous amount of openings. But they all, because I recommend them because they did well in my classes, right? Various classes right here. But the interview doesn't start with my classes. So they basically all fall off the cliff before they even hit my core class. And those are all bright students. So we decided that we're going to actually help our students to really prepare for the real world. And by creating those 2 courses, and these are additional fees that I'll talk a bit later, but just to make sure that our students could actually take it, we gave our UH students huge discounts on that. But in the end, we want that to be part of the curriculum, although those are not for credits, but you'll receive badges. You can put on LinkedIn, everything. But honestly, what you actually get is the skill set that prepare you for being a very, very successful engineer. Okay, so that's your, don't treat this degree plan lightly. And again, if you're not sure which one you should take, always email me. We can have a Zoom meeting before you fill out, or we can have email back and forth. And again, to support this effort, in the fall, we are creating 2 sections of embedded system, both in fall, but on different days. So to make sure that professor can take care of everybody in a timely manner. Again, we can have a size control in terms of class size. All right. And I will try to play this little animation a few times. Okay. And what's the difference between these 2? Not a whole lot, right? But then this gray box rise from the low point to high point. Okay. Why? The bottom part, the gray part, is our master's degree program, and the top part was your bachelor's degree program. But by taking the advantage of the accelerated bachelor to bachelor program, you're literally taking the same courses, but you are 2 ahead of other people in the master program. That means if you apply now, if you're a good GPA, you can apply any time now or in your junior year, and to take advantage of double counting 2 co-listed courses. And those courses will stay on your graduate program for up to 7 years. So don't think you have to commit for your master program full time. You can do that part time as well. But taking 2 courses off your list is tremendous help, especially if you're doing that part time. So there's no loss on your end at all. So what happens is that we have lots of co-listed courses. For example, the advanced micro P was co-listed as RTOS and IoT. And my ADD class is double listed both in undergraduate and graduate program. And you can only double count if you know ahead of time. And by the time you sign up for those classes, you have to sign up the 6th level course instead of 5, because the 5 will not count towards the graduate degree no matter what. So you have to plan ahead. And Dr. Trombetta is the one who's in charge of the program. If you are interested in, talk to him early and get the paperwork done, because some people just by themselves taking those advanced courses without telling anybody until later, that got lots of trouble. All right. Again, being in the program will make you eligible for many, many opportunities. For example, we constantly getting requests from the industry to say, can we have internship students? But junior or early years, summer, it's really not tremendous because they haven't taken core courses yet, right? And then by the last year, they're not eligible anymore because they're in graduating year. So being in this program, making the transition from bachelor's degree to master's degree actually a internship summer instead of an ending summer. So you're eligible for many, many internships that's available for advanced students. And also for me, actually, we sometimes getting sponsored projects at school, not in the summer, the whole school year, and students get paid. And if you're not in those long kind of commitment programs, you will not be able to take those because they don't want to fund a student just for 1 semester and you'll be gone. So if you can actually work for the last maybe couple of semesters in your bachelor's degree, plus the master degree, which you could get easily within 1.5 years if you actually plan ahead. And the company will actually pay you for your entire duration. And then they will recruit you heavily after your graduation with master's degree. So that's really important. So this slide shows you this new program, not new program, but not many people are aware of that. There is a GPA requirement, but talk to Dr. Trombetta to see if you are eligible for it. Okay. So the next one will highlight the new blue additions to this mix, because we found that if we pair this along with the embedded system or the advanced micro P, we can prepare you guys really well for any industry-based jobs. Because once you get to the company, you're no longer living in this ideal world. They'll give you a bunch of devices, And the hardest part for embedded system is not the actual brain part, because once you get the signal into the processor, you can do whatever you want. So the most challenges is to do with the signals. The devices are all of different standards on different buses. Do you know the actual principle instead of just name? Can you actually write efficient code to take advantage of the interface abilities? So the short course, which is an 10-week course, will address that problem. In addition, this one also tells you all the kind of junk components around the embedded board that unless you are really E intensive, you don't necessarily understand. Even people from our E programs probably only take those courses a while back and never actually have a use case of it. So when get interviewed, those are just names. They say, yeah, I definitely heard, but they never can understand and explain. So they literally fall off the cliff before they even hit the core embedded systems. So again, I'll talk a little bit about the program, and those are 10-week based and very light load. That means you can take that along with any of these courses without overloading your kind of schedule. And these will be module based. So we have 8 modules, each one focus on one aspect of it. And I will put in maybe an hour and a half up to 2 hours lecture. And the lecture will have 2 parts, the theory part and also the practice part. So we're going to use real ARM processors in the real-time operating systems and demonstrating how you can use certain bus standards to get the readings from different type of sensors, and also how to drive external outputs. And then the one thing I want to make sure is that people will enjoy this learning process. So there will be no quizzes and no exams. But you will have assignments. So we have guided assignments. That means you're not going to be scratching your head. So by following the steps in the lecture, you can actually enjoy the final product. You actually either repeat or modify to have an end result. And so both the embedded interface and UVM will be structured this way. And for UVM, which is a universal verification methodology, it can be taken by 2 sides of people. First, people who are taking my ADD class. And because we designed the chip, but we have to make sure that we verify that extensively to make sure it's working, right? So having the UVM formal methodology will be a plus when you apply for jobs. The other is that if you want to really like software, and you probably don't even take my course, you can still take the UVM, because UVM traditionally being considered a software job. Okay, but people who actually can design hardware has an advantage, because the way they know hardware can be designed and what are the corner cases that will be facing by hardware design versus software, make them a better verification engineer. And then these are useful also with my advanced hardware design course, which is the graduate level embedded course, and my we have official FPGA and AC verification course at graduate level. Okay, so actually I actually pair those classes with those advanced classes as well. So this short course is shared among the undergrads and the grads, but we want to teach in a way that everyone can understand. I think the bottom line is, if ever taken micro P, don't even have to fully understand it. Okay, we want to teach from there and making sure that you truly understand and enjoy embedded systems. All right, so that's the course that we're going to actually experimenting with what's called a course companion starting this fall. So I think whoever signed the degree plan last year, they will get an additional notice on this. And so they will be notified to take this course in addition to their planned course. And again, this is not for credits, but definitely prepare you to be a better engineer. Okay, and then we really want to help students to actually deal with the, I think, added burden on financial side. So you will see later, we give deep discounts to students, making sure everyone can actually take that. Okay, and I want to make sure that people understand the difference between our courses versus outside the online courses. The short course will be online. It's called Asynchronous Online. Actually, I think people heard about how I taught my AD class in past few years. They will tell you that my asynchronous online course will feel a lot more interactive than any of the in-classroom classes. So I got very, very successful experience. So I will be producing all the courses. I will get help from Dr. Harry Lei to prepare the course materials together. We'll test all the hardware we're gonna demonstrate, but I will be teaching the courses. I'll be the only one who will be recording the courses. I will be the one who direct how we should present each module, so you get the best benefit out of it. And then the other differentiation factor of us versus the outside cheap online courses is that we actually teach the real thing. That means we don't just teach the syntax. For example, UVM has extensive libraries. They have lots of syntax structures. Almost all the outside lectures that they teach one by one, these are structures. When they demonstrate, they use teasy examples, how to test an adder, how to test a deflipper. Everyone knows how. But after taking that course, you still don't know how to verify a standard industry standard modules. So we teach on the other way side. So we can actually present a really sizable design from industry components and industry quality controller. Then we don't teach language necessary. We take that, we say these are needed to test, and also we study the specification. That's the right way of teaching the verification course. Then we decide, okay, what I'm missing, what UVM can help us. Then we use the need. Then we show you these are the components that can help you to make that testing environment set up, and these are how you actually drive it. So we teach top down. That means we want you to learn verification methods, not just syntax. It's almost like if you learn a new foreign language, I learned the rule book, the grammar, but I can still not talk, right? So that's the same thing. I'm actually trying to learn Spanish, but I listen to the lectures from universities. I know not all, but most of the rules, but I still cannot talk. That's a real thing for me. So I'm still struggling and trying to at least devote to maybe 10 minutes a day, but not a whole lot. But I feel like I know the rules. I can tell you, I even can get the lecture about the rules, the grammars, but I cannot speak at all. Okay, so the difference is this, and also we have human behind it. Your work will be verified by our instructors and TAs, and there will be no multiple choice problems. Okay, and you can actually get in touch with the professors during the course anytime. People who took my course and knowing that they probably get 3 minutes reply if they're lucky enough, but definitely within a couple of hours, we will get reply. All right. So, and this one, we gonna actually, this first time we're gonna put this as a course companion for the two courses, both the embedded systems as well as the advanced micro P part. So, and you have a choice to take the interfacing course only or the UVM only. Those are the people who are taking actually my ADD class. But if you think your field actually you're gonna touch both, you want to take the combo. Okay, and for the fall, we will give a special rate. Usually we get discounts when you sign for both courses. But if you're in the 4437 for the fall, and again, another one is my advanced hardware design, which is graduate level embedded. They can just take a single interfacing course getting the combo rate, okay? And then people saying, Dr. Chen, what if, especially this cloud, you probably won't take embedded until fall next year. Okay, what happens? And again, you can see these are the fee structures for each of the courses. The regular price is $24.99. And then for people with referrals, you get $17.99. And these consortium memberships are the collaborating industries. If they send their engineers to our courses, they get $15.99. But I understand that these are the huge kind of amount of money for our UH students. So we literally pushed that down, and we got a special approval from the university that we are allowed to at least getting the regular rate of $7.99 each course. And we plan to keep that for our students and alumni for quite a while. Then, because we are pre-launching these courses, and you get a special rate. Okay, so currently, if you take you decide to sign up for the both courses, you get $5.99 for the UVM and $6.99 for the interfacing. That's including the hardware you need to purchase. And then that's by payment by July 15th. But then I'm starting to worry about the audience today. You won't hit those courses until next year, right? So I actually made a new category called prepaid rate. So this includes anything about embedded or advanced micro P that people plan to take in 2024. So if you complete a form and also pay by that date, so I'll make a note that you won't take the course when you pay, okay? I will put it into your next year's schedule. So when you actually have your classes kicking, I'll put you during that time. And because after July 15th, the price will be $6.99 plus $7.99. Okay, and I think it will stay that and up for the rest of the time in the future. So I think that's a huge discount if you actually can decide to come in now. That's $200 off. Okay, and these are also like a couple of $100 off our regular prices. And for a single course, again, you pay only $6.99 if you actually can commit by July 15th. And from that point on, it will be $7.99 for the rest of the course. So if you think definitely you will hit either 44.37 or 54.36 next year, and I don't think the banking interest give you such a high rate. So I think you will be seriously considering taking that advantage. Okay, so those are called pre-launch rate, and those are only valid till July 15th. All right. Again, so if you decide to prepay for next year, there are a bunch of options. You're eligible for that rate. If you will show me that on your degree plan, you'll be taking interfacing, UVM, and so on by next year. Okay, so I will send a form, and once you decide to actually sign off on degree plan, you decide to do a pre-launch rate, you'll fill this plan. But if you decide I'll pay later next year, then this is the form that you don't have to fill out now. All right, so again, I need to still talk about how to get to the degree plan. And first, you have to download the e-degree plan. And there are two versions that will be coming up in the next few weeks. One is the one I showed today. And the other is the new one Ms. Amanda is creating now. So she said, once it's in place, you can fill out either one. That's just a different looking. It doesn't affect the content. The second one is that if you cannot actually come in today in the live session, I will send you a recorded talk. Oh, sorry, it's not the CP, it's an e-talk here. And then you will watch the video, and then you'll come back to me and for the degree plan advice. And then at that time, you'll send me your draft degree plan, and then I'll respond back to you to correct maybe some mistakes and so on, and then we'll finalize it. Okay, so after we agree on both ends, I will sign your degree plan, sent back to you. So at that time, that's not the end of it. So starting this year, all degree plans signed by me need to fill out this degree plan information form. Older days, only people who will have 50 for 40 on the degree plan will fill out the form. But since now we're having these two short courses, I need to reach all the people I sign off on degree plans. So I will send you a link along with the signed PDF file. I'll send back to you. I'll send you a web link for the form. So making sure that you click exactly when you plan to take the key courses. And also on that form, there will be information about short courses you'll be acknowledging about. Again, for people who want to take this pre-approval pre-launch rate for this year, and you will additionally complete this pre-approval form, then make sure that we receive payment by the certain dates, and then I'll put you on schedule. On the form, you will say when to actually activate the course. Okay, at that time, I'll contact you and making sure it's launched on the same day. Oh yeah, the other benefit I give to a course companion package is that Normally, you can only access the course for 10 weeks, and normal students will need to pay additional $100 to extend to longer period in case they cannot finish. But for anyone in my list of courses, I'll give you a full 3.5 months aligned exactly with our long semester. And you can go back to the material all the time when you actually, whenever you want to work on project and you encounter the interfacing problem, and then you can refer back. And this package will really well prepare you for your senior design course, because that's when your idea hits the, the real time, the real world. But the students here, they literally get another $100 off because it was a free 100 extended period of time. All right. So the other thing is that when you again, after you fill out these forms, don't forget to submit to Ms. Amanda using the submission link. I think the early talk is saying it's basically going back to your original PDF for the degree plan, because the one I sent back to you is image of PDF. The link doesn't work anymore. Okay. And then how to fill out these, and these are all the choices. So the top one, as I mentioned earlier, you really should pick 4437 as a mandatory elective. Okay, it put my 5440 as the general elective, because otherwise your degree plan will not be complete. Then you have to take the computer architecture course and also check your computer science schedule for intro to programming. So the rest, I think they are not really equal. As I mentioned, my course is highly appreciated by the industry, but it's not for everyone. Only apply for this if you really plan to put extremely hard work into it. The other thing is automatic control system. As I said, all the systems involve some control laws, and if you don't take them now, it's so hard to kind of to understand those and truly grasp the content of it after you get out of the school. Okay, and again, other things are all good, and I hope you have enough time to put these into your degree plan. If not, consider some of the courses are co-listed as a graduate program, and only 4437 is not co-listed in the advanced courses, so making sure you take that. So if you have to choose this versus advanced micro P down here, fill out the 4437 first, because you might be able to hit advanced micro P another time when you're in our graduate program. Even if you're not in the auxiliary program, I encourage everyone to join our part-time master program. Now, all our master courses can be taken online. So it'll be marked face-to-face, but all the instructors are required to either Zoom in real time or post a recorded session for the full class online. So actually I have students actually living in Oregon now. They're in this master program, and now he graduated from this program. Now he's in my PhD program. Yeah. All right, so a couple more things, I think finish the talk. These are kind of, try to pre-fill those fields, because I said, number one, pick 4437 as mandatory elective, and that's a fall only class. And then the computer architecture, as I recall now, it's spring only, but you need to double check. And for CS schedule, you have to double check with the computer science department. And I expect most of you probably will go to advanced micro P, because I think embedded is considered embedded process by 95% of population. My FPGA chip is kind of a, yes, it's a computer embedded structure, but it's a special method that we actually design FPGAs and processors. So, but if you really like the challenge and you like that you have to take care of everything without OS or without no piece of additional software, you want to tell me, in addition to filling the degree plan, why you love my class, why you are ready for it. I need to see the readiness for it, because I want everyone who is taking my class getting an A. I gave an extremely amount of A's, especially for undergrads population, not because I gave easy A's. If you look at the items they completed for the entire semester, there's reason why they're getting A's, but it's not good for everyone. So if you cannot meet the challenges, then you are falling behind and behind. I don't even want to see B student, not even say C or D or worse. So I want everyone to be in my class to be successful. Otherwise, you occupy one slot that could be given by to other people, because usually there's a 1 year wait time for my class, but only apply when you're ready. Okay, the second one, the section is for EC electives. I would say always say read the instructions. Okay, and people just blindly just putting things in there. And if you, this is pretty obvious, and once you pay attention to it, you know that it counts all the EC electives right here. And then the technical electives, we actually have lots of outsider classes. And also there's one tiny little print here. It says all ECE 3, 4, 5,000 level courses are counting as electives. So I think unless you really have a love for outside classes, I would say you will not go around to take one additional class here in our EC department. As we say, there are so many good classes you can take. But if you're ever going outside our department, putting your course on the degree plan doesn't mean that you meet all the prerequisites for those classes. First, I have no idea about the prerequisites for those classes. The second one, I don't have access to any database of the students or record. So you need to figure out yourself. You have actively approaching those instructors to double check if you meet the prerequisites way before you plan to take them. And some departments give us waivers. I know the mechanical department giving certain waivers for certain courses, but not all of them. So approaching them, you are the driver again, as you see that you have to drive yourself through all the curriculum and making sure you will emerge as a qualified engineer. All right, so again, so these are the electives labs you have taken. Those are not additional new courses. Again, read the instructions, okay? And basically you go to the previous pages, sections. If you see a 4, that has 1 lab credit. Or some courses like control, they have a split sessions between lecture and the lab course. So you can just put the lab section right here. As long as you meet 3, I don't think the DLD will count towards these elective labs because it has to be on the section 1, 2, and 3. But our embedded systems students don't have problem meeting those because there's so many with lab credits, inner networking, for example, and my course, embedded course, advanced microcopy, and so on and so forth. So that's important. And again, although Ms. Amanda do not require you to turn in the scheduling page, I do require for anything I sign off because our courses are all offered once per year. Okay, if you mess up, you just click, and later on you end up saying, oh, I have 6 courses in 1 semester. That doesn't work. So I want you to really plan those out. And by Googling a EC spring fall, it will actually, our page will come to first or second, click that, and you see all the undergraduate courses listed and which semester they are offered. Okay, and put into the right semester, you want to explicitly starting fall 2023, and for each semester, which are the courses. This also helps you to figure out, am I overloaded? Because all senior courses are very heavy loaded, and my course especially. So don't put 5 courses in the semester when you want to take my course. Okay, I'll sign off on all these. And then once you have this, when you turn in, don't just submit the form you fill out in case you fill out electronically. Then I'll have whatever coming off Miss Amanda. And then when I save to my drive for signature, I have version 1, version 2, version 3, and so on. So make sure that you rename that into embedded degree plan and put your last name and first name as part of file name and email to me. And to avoid me missing your request, put the embedded degree plan and your last name. And then in the email, explain whatever you want to tell me. Again, in case your draft degree plan has 50/40 selected, you have to tell me the reason why you're ready for it. Okay, I may just sign off instantly, or I may have back and forth a couple of rounds. Sometimes I have interviews with students. And the other thing is that people usually get in for the senior year. So when you get the degree plan signed, most of people will be placed in the senior year. And then actually, before you fill out the degree plan, because I just realized that students don't have full version of Dolby, so you cannot type in race. So before you fill out this, if you want to put my part first, you have to get my email approval first before you actually do that on degree plan. I don't want to redo the degree plan. And also I'll tell you which year you'll be placed for that course. I take maybe a few students every year, either they're in the bachelor's to master accelerated program, or they are competing for my next year's TA job. So you have to tell me that the reason why you want to take that early and how you are capable of doing that. So once I approve it, then you can go back. So for example, if I approve you for early, then you can take at the spring semester in your junior year instead of in the senior year. But just expect majority of you will be taking that in the senior year. Okay, once you have this, again, I said earlier, email me again if you don't hear back from me in 24 hours. And it'll be longer over weekends, depending on what I'm doing. And then you get the sign form back. But in between, we may have a bunch of email back and forth just to make sure you're fully informed. And then you will complete the link I sent to you with the degree plan information form, so we can reach out to you at the time. And if you have 50/40 selected on your degree plan, then you'll be automatically put on the priority list for that. So this year, I think for those people who are on the priority list, when the time is set for you to take the course, I'll send the list directly to Ms. Amanda. So you'll be added, your ID will be added. Then you'll get an email from her saying that you're qualified. So at that time, I'll email you guys. And again, if your plan is still stay the same, and that's okay. In case you change your plan already, say, Dr. Chen, I don't want this course anymore. Email me immediately when I approach you, so Ms. Amanda will not actually get you authorized and take you off. Okay, and again, if anyone's interested in this round, a special pre-launch rate, you will be actually filling out this one as well. Again, during our email exchanges, if you're in those cases, you do want to ask me about it to know more information before you actually make commitments on the payment stuff. So don't just blindly fill out the form without telling me that you're scheduled for anything 2024 or later, but you want to prepay for it. So I want to know the situation and give you proper advice. I don't want to overly commit. So that's the things going on. That's new for this year. So that's all I have. I think it's the best time for you to be in this program. And what I want to say is that our university is trying to make into top 50 engineering school in near future. To me, I'm more passionate to prepare students to fit expectations. And our students are doing so well, and sometimes going against the current graduating students, because I arrange so many students to get interviewed by local industries. Because they got excellent students from us in the past years, the bar is going up and up and up, because they use our golden standard, which are actually who are my students mostly. And so the entry bar gets higher. So I will have to better prepare you for that. But I think once our UH get in the top 50, and I will be preparing you guys to equal and better than the top 50. Honestly, when you actually look for jobs, they really want to know, what you can do, especially hands-on. To me, theory alone is not enough. I want to see things in action. Being a hardware, being a software, I have to see things running in front of my eyes. And a few years ago, we had a position locally, and I was competing between my student versus a student from CMU, Khalid Manan, who has a #1 computer engineering program in the nation. Guess what? My student beat him. That's the quality that coming out of our program. And again, for people who don't know, Dr. Harry Lei, and he is a longtime HPE engineer. He had over 35 years experience, and we're lucky to get him after he got retired from HPE. So he's full-time with us. And for the 2 short courses, and future, we'll produce 2 more next year. We literally co-design the entire curriculum. We design all the case studies. We wrote the code, okay, for demonstration. So it's end-to-end, completely taught. And again, I've been passionate so much for as an engineer. I started out as an engineer, and honestly, I learned very long from industry. I never taken any ADD class in my all complete education from bachelor's to master to PhD, never taken a single course on advanced digital design. I learned those in the industry. I was so passionate about it. And I create this ideal course for ADD based on my dream. So now the dream came true. So yesterday, a student came, asked me, Dr. Chen, you get this, all the recordings of all the lectures. Do you have a team to produce that? I said, no, not a single person, only me. So complete thing from the idea to production to editing to finalizing, only me. Yeah, with the help with what my $1,000 audio equipment. I bought this microphone was just portable, but at home I bought for the courses the condenser microphones along with audio amplifiers. Just make sure that for the entire duration, students will have a pleasant experience. Yeah, because it has to be the music to the ear. Right. So I think the students were amazed. I was a single person behind it. But this time with the short courses, actually we prepared as a team on the material side, but I will be teaching exactly the same way as my now famous ADD class. So I'm looking forward to those, and I'm looking forward to getting degree plan from you and getting to know you personally. Okay, do your rest of course at the UH. I want to prepare you guys to be the best engineers in the world. All right, okay, any questions? Okay, not really. I think it's really long. I think people will just listen to the recordings afterwards.
Yeah.
Mhm.
Let's see.
Yeah, okay.
Okay.
Yeah.
All right. Thank you, everyone. I think with that, we will conclude the spring 2023 student advisory. Thank you all for coming. We will be uploading this onto YouTube, and yeah, keep an eye on that. We'll be announcing it on the IEEE Discord, and we'll try to share it as best we can. All right. Thank you, everyone. Okay.
Okay.